Hello, everyone, and welcome to the new episode of Entrepreneurship Lab. This is your host, Nevena Bajalat, welcoming you once again to the podcast where we help you grow and scale your business. Today, our guest is an experienced expert in software development. He's actually a technology leader with over 25 years of experience optimizing software development and helping teams. And he worked actually at Uber and led the technical integration of the Jump acquisition, scaling from 45,000 vehicles to 2 million monthly trips and generating over 150 million in annualized revenue. His name is Thanos Diacakis, and Thanos is here to share with us what you should know about developing your software in your startup. Thanos, thank you for being here.
It's great to be here. Thank you for having me, Nevena.
So I'm super excited to hear a bit about your story. Are you originally from Greece and you live now in California, right? And have you always been in tech? How your journey started as well? Like you very passionate and obviously an expert in this area.
Yeah, I am from Greece, and my journey started westward. I studied in England, and then further, I went to Carnegie Mellon in Pittsburgh, and then continued going further west and west as my career progressed. And now I've hit a big ocean, so I think that's kind of my stopping point is here. But my background was in information systems, and once I graduated out of college, I started a company that was near the dot-com era. And then worked in a variety of startups in different roles, CTO, VP of engineering, and became really familiar with the process of building software. I did a stint for about 5 years where I was building hardware and software in for different startups, and that was a lot of fun learning how the different timeframes work for hardware project and software projects together. And then after that, as you mentioned, I went to Uber. We worked on the Uber Bikes project, which was fun because that had both hardware and software. The bikes had a lot of complicated
Mhm.
hardware and software that we worked on that. And it was a lot of fun bringing it from nothing in about 2017, where there's like zero bikes to a lot of rides and figuring out the whole new micromobility. And now, whatever city you go, you can see lots of bikes and scooters that you can rent. So it was a lot of fun seeing that, and the pace of that project was just amazing. And then after that, I also worked for another big company called Included Health, which was a few hundred engineers. And throughout my career, I've generally looked at the process of building software and what does it take for startups to build software and what are the common mistakes that companies make. And in my current role, I'm helping small companies, 2 to 5 to 10 engineers that are struggling putting out software. They have really smart people, they're really busy, but they're struggling to get the development work done. Timelines are always slipping, and I help these kinds of companies become better at it, go faster at it so they can be successful with whatever their business is.
Yeah, that's amazing. And you achieved so much. Yeah, super young. So tell us a little bit about, first of all, when a lot of startups start, yes, with the software, everyone eventually maybe need their app, their platform, they need technology integrated to help their business. Where do you think they should start? And do you focus maybe on the research or assessment? Where is like the starting point for someone who is just starting from zero?
Yeah, so you mentioned research, and that's always a fun place to start because you can see that usually two extremes, right? One is the type of company that will not take a single move until they've thought about it and researched it and planned it out and know exactly what they're going to do for the next year or two or three. And then there's the other type of company that's going to not think about it at all and just jump in and start doing stuff, right? And I think neither of these works really great. You kind of want to do like enough research where you kind of know what you're doing. You don't want to like because software is really expensive, right? You have to hire engineers and they cost a lot of money. So you don't want to just have them just doing stuff at random because that's going to cost you a lot of money with no output. At the same time, software is sort of very malleable and flexible. So you don't want to have, write it down and write like 10 pages of 100 pages of specifications and wait like 6 months till you write your first line of code because you're only going to learn by actually doing something. So what I usually advocate for companies to do is just do a little bit of upfront thinking, right? Think about the big picture things, maybe figure out what are the big risks and are there things they can test out by doing things on paper rather than with software, but not spend too much time on that, right? Once you have enough of the ideas, go get to do something and learn from it, right? Go put a little version of your software out and try it. A lot of times we have some really strong idea as a startup as to what our users want, but a lot of the times it's not exactly what they want. So the product market fit isn't exactly there. So I say learn a little bit and then just go and do something and figure it out from doing it and get good at doing little bits at a time. Does that make sense?
Yeah, absolutely. And I know that especially in tech, like you said, people put so much money and even developing MVP, they don't put it out for a long time. And then it's either outdated or the technology changed so much and the market changed so much. And then they develop a software and realize, oh, it's actually not something that so many users wants to use. And at the end, if you don't have the sales and the users, you cannot monetize. It's difficult. You cannot grow business out of it. But then, what are some mistakes that are most common in this area building a software?
Yeah, you almost mentioned one, right? The trap of building software and then always trying to chase the newest technology. Software is a tool, right? We want to use software as a tool to build our business and be successful because we sell something that users find useful and valuable and they want to pay for. A common mistake is if we don't understand technology, we might hire someone that does know technology, but they're too into technology. So they're building technology for technology's sake. And that's really bad. We don't want to be chasing the latest tool. We want to be chasing a tool that is good enough to build what we want to build. So instead of focusing on, oh, this is a really cool thing, let's use this, or oh, that's outdated now, let's pick the new shiny thing. So let's focus. What do the users want, and what are like some pretty boring standard stuff we can use to build stuff? People always seek like the latest and greatest and fanciest thing to be successful with something, but find boring technologies, find stuff that you know that works, you know you can build it. You're not going to be on the cutting edge finding all the most recent bugs because the thing that you're using is 2 months old. Again, you don't want to be on the other extreme, right? Where you're writing with Fortran or COBOL that was from 50 years ago, and you can't really write new stuff. You want to have some forward-looking capacities, and you will need to spend some time if your business has been around for a while to updating your things. And bring the technology up to date because that's what's going to enable you to continue to be able to do development. So that's kind of one important one that I see done a lot of times. A second thing that's worth mentioning is a lot of times business owners that don't understand software think of software engineers as machines that write them new features. And to say if I had one engineer and I can get X features done, if I have three engineers, I can get 3X features done. And that may be true to some extent, especially early on, but it doesn't scale forever. One of the things that I advocate is that business owners and technical leaders start understanding what happens inside these engineering teams. These teams don't just write features, but they have other activities that they need to do. When you write a feature, when you spend a few months putting something out, you're going to have some bugs. So you need to allocate some time to fix these bugs. If you've been at it for like a year or two, you're going to need to do some cleanup. Your architecture is going to need to be rearranged. You need to go change some things around. We call it tool sharpening. You're going to need to go fix up the systems and the processes and the perhaps engineering culture that you have to stay up to speed. So maybe like 30% of your time, and again, this depends on the maturity of the team and the phase that you're in, but just pulling up a number, maybe 30% of your time is going to be built on features, 30% of your time will be spent on sharpening your tools, 30% of your time will be done on bugs. So it's not like you can just keep adding engineers and keep scaling this thing forever. There's other activities that you do. And companies that don't pay attention to this, they get in a hole. They get to the point where they have so many bugs, they just spend all their time fixing the bugs, and they don't have the ability to put new features on because they're so busy and unhappy with that. So that's another very common one that I see out there.
Yes, and very interesting. So, what are some things that maybe some stories? You help Uber scale so much in that project you worked on with them for a couple of years. So, what were some interesting stories you had? Maybe we can call them mistake or something you discover that, of course, you learn from and help you understand the things better. And it was a great experience for you.
Yeah, I think the one that I was mentioning with the technical debt is a fairly common one, right? And we had this at Uber. We did an acquisition and we bought a company called Jump that had the bikes and scooter technology that we wanted to do it. We had some in-house technology and we had to spend some time together merging it. So at the same time that you wanted to get this thing out to the market and be the leader and have the most bike rides, most revenue from all this, there's also a lot of work that need to be done internally to clean up the systems and maybe rewrite some things. And there's some systems that were 6 or 7 years old that needed tidying up. And when we first did the acquisition, we spent a lot of time with the joint teams, learning how to work with each other. And it was tough. It was tough because you get woken up in the middle of the night. And the teams were so we had some teams in Europe, we had some teams in the US, and the pager goes off at 6 in the morning that no one is able to take bike rides, and you have to jump on and go on your laptop and not having had coffee yet, figure out what the heck is going on and take care of it, and the teams would pull together and get that done. So that was really exciting days. And having to balance that, right, with, okay, guys, we need to get more and more bikes going out there, but we needed like, maybe take 2 or 3 weeks off and just sit down and fix some bugs. And I remember we had like a big code yellow where you had to just pause everything for a few weeks and just do a little bit of cleanup. I remember we were paying for the most expensive database that Amazon had, which was tens of thousands of dollars a month, and that was insufficient because we had something written in a fairly inefficient way. So that was part of the going through the technical debt, sort of cleaning that up, making that a bit more manageable until we can go back and build more cool features that related to the bikes.
Yeah, and I mean, definitely exciting and tiring at the same time, waking up in the middle of the night trying to clean the software. And a
Yeah,
lot
it
of
was
people
crazy.
do not see this behind the scene, but at the end of the day, you have to make, customer happy and the user friendly, so they come back and they use it again. So how is in this situation, how important is customer service? Of course, you as an engineer, other engineers are on technical side, but in companies, how important is the customer service part where they're communicating with the users at that point? If there is a bug and to keep the database and people coming back to their app or their software to use it, how should companies navigate that part? Because it's very important.
Yeah, so one of the super interesting things is the role of engineers in a company that writes some software, I think is massively critical for engineers to understand the customers. And you mentioned customer service. One of the things that I've seen done, and I advocate that we do in many companies, is have the engineers work with customer service because the engineers can see what the problems are in the business. And they're often very creative in saying, oh, wait, you're having this problem? We can fix this in like 5 minutes. And
Yeah.
then you won't have to have all this customer unhappiness or do all this manual work. So obviously, customer service is super important, right? The customer is who has to be happy to keep coming back and buy your product. Um, but we usually with engineers, you have this disconnect, right? You have some kind of product management or business owner that creates the requirements and then throws them over to engineering, and engineering implements this without really much thinking about it. That's not sort of the best model. I advocate that usually the product owners, the customer service, the engineers, the designers all kind of work together because they can take their expertise as a whole, bring it in one place at one time, and be able to have this high stakes, high bandwidth collaboration to figure these problems out. Sometimes the product owner will have a suggestion, and the customer service will see and be, no, 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 this is not exactly the problem we're having. We're having this problem. And the engineers will look at it and be, oh, yes, and we can solve this in these kind of ways. So these super effective, small kind of group collaborations are able to get you to close those feedback loops and be able to take the feedback from all the parties that have the right information in their heads and collaborate and create like a really, really good product. When you have this model where someone like gets the feedback, writes the specification, throws it over to a different group, they do some more work, they throw it over to a different group. It takes way too long for the feedback to reach from the end back to the beginning, and that makes for kind of like bad products.
Yes, and in the end, like you said, it's you are developing software for the user, for the customer, right? And not for the business owner, what he imagined. And how do you see the market and among the developers, engineers, designers, all the roles, right? How do they prioritize? Maybe it's individual in the companies. Are they excited? Do they like to work with customers? And they're just like, oh, another complaint, another headache. Like how is it in general and how should it be, right? How should we position it?
Yeah, there's been in the last, I don't know, maybe 20 years, kind of the perception of the really good engineer that you put them in their cubicle or their office or their desk and they just work and they're better than everyone else and they crank out, but they don't like talking to anyone. And if you ask me, I would never hire that person because if you have a very tiny company that maybe has one engineer and that's your engineer, maybe that would work. But as soon as you have 5 or 10 engineers, the problems that you have are more about collaboration and coordination. And sure, you have to be good at engineering, but if you're not willing to talk to other people, you're not going to be very successful. So I really want engineers that are happy to talk to other people, that really are interested in the customer problems, that want to go and talk to different groups and coordinate these solutions. And if someone is kind of the grumpy person that just wants to do engineering, they're likely to be the person that loves like tinkering with new technologies, and that's great. But it's the customer experience that matters, not necessarily like what tool we used or how many hours you spend in your cube writing your software. So I will aim to hire those good collaborators all the time because I think that's how you get your 10x engineering is by having a team that is cohesive, that is multidisciplinary, that has all the right um, knowledge and expertise and likes talking to each other.
Yeah, yeah, absolutely. I agree. So for delivering actually the software, what are some models to make effective software delivery? Can you share that with us?
Yeah, so I have on my website a PDF document that folks can download that outlines 7 mental models that change your way of thinking of how to do software delivery. This is intended for business owners that sort of understand how technology works, but maybe aren't really quite sure. I've mentioned sort of one of them, which is that we don't just build features, right? That there's 3 or 4 things that engineering teams do and that you need to apply yourself to this. There's some others in terms of having like a single button. Like if you look at a team, there's usually one thing that is controlling the speed of this team. So think of like a factory, right? If you have a factory that has a sequence of machines that are building some kind of widget, if one machine in the middle is slow, if you fix the machines before it, then that one slow machine is going to have a pile of work coming to it and nothing happening afterwards. Or if you fix it afterwards, the machines are starved for work. Now, software isn't as simple as a factory, but you can think of the same thing, right? There's usually one thing that is slowing you down. So, figuring that out and figuring out what is that one thing that is slowing you down really helps. Another interesting mental model is thinking about what really matters in software delivery. And what matters is shipping. You want to ship useful, good product to your end users. It doesn't matter if everyone's really busy. If they're busy but not producing something, you might be what we call locally efficient, right? Like everyone in the team, like there's 10 people, and everyone is working 8 hours a day. But if there's nothing coming out the end to the users, then it doesn't really matter that you're locally efficient. What matters is your company needs to be globally efficient, that you're putting stuff out. A common way to see this is what I was mentioning earlier. Like if you have a designer that ships, like writes a spec and ships it over to, a product manager writes a spec, ships it over to designer, they design the screens, they ship it over to engineers, then they ship it over to testing, then ship it over to deployment. You could be doing that, and everyone's always busy and they have a pipeline of things they're working on, but maybe what's coming out the other end has a bug and then it has to go all the way back to the beginning and get reworked. And that takes a lot of time and causes confusion and causes bugs. Whereas if you had a small team, they work together and they focus on getting things out the door. That's sort of the most important thing that really matters. So if you can rearrange how you work and what your processes look like, that really makes it much more effective. And people can go and download the rest, as I think there's some interesting stuff in there in terms of mental models. But moving sort of past that with some of those ideas in people's head, one of the things that I advocate is kind of think of your engineering in like 4 steps as to how you develop different capabilities. We mentioned a lot of teams reach for planning before they have the capability of delivering things. So when I work with clients, I usually advocate that the first thing they need to do, phase one, is iteration. They need to get really good from taking an idea that they have in their heads to being able to put this in production, whether this is an app or a website or an online, a SaaS application, whatever that happens to be, in a short period of time. In short, I mean days, maybe hours if you're really good, maybe weeks if you're just starting, but not months, right? And you need to get good at that first. Like there's no point in trying to plan a year out if you're not good in delivering like a small feature in like a few days or a week or something like that, right? So I advocate that companies start with phase one, which is get those iterations done correctly. Then phase two is quality, right? So once you can like iterate, you want to make sure that what you're putting out is good. That involves doing some kind of tests, understanding your systems, having like some kind of dashboards or monitoring that see how your users are using these features and getting really good at that. Um, the third phase here is then complexity. As you start getting good with iterating, you start getting good with keeping quality, you build more and more and more and more stuff, right? And at some point, this collapses under its own weight. So then you need to look at it and look at your architecture and say, does this need fixing? Do we need adjusting? Do we have too many tools and processes here? And then quality starts to get better. So we had iteration, we had quality. We had architecture, sorry, we had complexity and architecture. And the fourth phase now is you can start looking at planning and predictability. And you can say, okay, now we're pretty good at putting stuff out every week. Can we put a roadmap that covers like 3 months or then later 6 months? And you start getting better at planning and working with the other stakeholders because, sometimes let's see your sales will want to know what can we sell 6 months from now, a year from now. Now, I present these as linear. They're not always linear, right? If you have an existing product, you might need to jump around a little bit. But if you find yourself that I think you're jumping around too much, that might indicate a problem that you might need to go think about it. But it's easy to think about like, one, two, three, four steps. And did I get steps one and two before I jump into step three?
Yeah, super cool and very helpful information. Thank you for that, Thanos. And I want to ask you, you work with so many teams, with so many companies, so many engineers and developers. So what is the difference between a developer that's very productive and one that's not? Because I think that applies not just for developers, but for people in general. What are some qualities or some characteristics? Is it personality or is it the some things in the knowledge and experience? What is something that differentiates those developers that can do things faster and better quality than those that don't?
Yeah, I think that's a really tough question. I think every company that I work with struggles with that in figuring out how they want to hire.
Yeah.
My last company had a motto that we like smart people that get stuff done. And I think that's a pretty good way to get started. Getting stuff done implies a few things, right? You need to have some knowledge about how things work. You need to have some skills, like the hard skills of engineering to be able to do what you need to get done, but maybe some soft skills of collaboration. Um, One thing that I always look for people is do they have the not just the ability, but the willingness to learn. There's a lot of engineers, they went to school, they learned a few things, and now that's the way of doing things. And I don't find that these engineers become very successful in the long run because
Mhm.
things change. And if you're stuck in sort of one way of doing things, you're not going to be very good. We have this new thing of AI that has come up, right? And some engineers don't use it. And I'm sorry, but like while I'm a little skeptical of is AI gonna, change absolutely everything, it definitely has changed a lot of how you work as an engineer. And if you're not using these tools, you're being left behind. Right now, as I'm using AI tools in my with my various clients, it really speeds you up in how you do things, and you have to learn how to use it to get better at it. So engineers that are willing to learn and interested in improving themselves, I think is one thing that I would really be strongly looking at. One question that I often ask in interviews is, how do you improve yourself? And I expect someone is going to come back and tell me what sort of books they read or magazines they read or how do they stay current or classes they've taken. And get really
Yeah.
specific. Okay, so what's the last one that you took and what is the last thing that you learned? And I'm really
Yeah.
looking for people that have that in them and want to find that out. So
Yeah.
I think that's some of the big key ones that I'd look for.
Yeah, and I love that one, especially, I mean, especially in technology. I think in every occupation, you have to go on with the trends, you have to change the market. Every company every 6 months has to innovate and do something. You have to put something new in the market to be relevant. And especially, I mean, as a developer, technology is changing so much. And actually, so many people are losing jobs that I know right now because they're not up to the speed with development of AI and the new things that are coming up. So, thank you for sharing that. And I want to wrap this episode with maybe a final advice from your side, something that we didn't mention and you think it's very important for everyone listening.
Yeah, so maybe I'll close to something that's related to what you just said, right? And a lot of teams in software will do the work, but that's not sufficient because all other companies also do the work. And what you need to do as a team is also continually look at how to improve the ways that you do your work. So, because otherwise you're going to be left behind. So you have to look at not just delivering the software that you do, but continuing to introspect. And every week you're doing some new experiment and saying, hey, can we make things better? How can we make the technology better? How can we make our people better? How to make the processes that we have better and keep improving those? Because if you don't, then someone else is going to do that and then eat your lunch.
Thank you, Tana, so much for your time. I really enjoyed, and there's so much value for everyone listening.
Thank you for having me. This was great fun.
Yeah, perfect. Guys, remember to download the episode, share the podcast with at least one person that can benefit from this information. Connect with us on social media and LinkedIn, and go to him if you need any kind of expertise in developing your teams and your software companies. Thank you for listening. And of course, I will see you in the next episode.